Hello, and today I'd like to talk to you about how machine learning is becoming pervasive on the service desk. So the service desk, is very much a cornerstone of IT service management. It provides that single point of contact for users and ultimately provides a range of services. But the expectations of what people have today have changed from when the service desk originated. People expect very much an always on service. They expect that to be tailored so they understand about them and their needs. And ultimately, in this day of social media, they expect immediate gratification. They expect results quickly and efficiently so they can get on and do what they really want to be doing. Delivering against these expectations is a challenge. You can't just keep staffing up to deliver these expectations. You have to work in a different way and meet the users where they're at. One of the ways of doing that is to use machine learning. And today we're going to use the incident management lifecycle to illustrate what that means. From the initial interaction with the user all the way through to resolution, and how ultimately machine learning and those technologies can underpin the service desk and drive those efficiencies. So let's have a look and see what that means. So let's have a look at the incident management lifecycle. And it's broken down into 4 areas. So it's the initial interaction with a range of different channels available to the users. No longer is it just a telephone call to an agent. There's the identification and classification. So once the demand has reached the service desk, what is it? And where should that demand go? Ultimately, there's a response to that demand. And then, so outside of that cycle, there's the analysis itself. So meeting the users where they're at is really important today. Meeting them 24/7 on a range of different devices and methods is very important. Efficient classification and identification is important because you want to get that demand to the most appropriate resource that can deal with it. And that resource obviously no longer has to be human, it could be a machine, but we'll look at that a little bit later on. Response is where the bulk of the time goes, so you really want that to be efficient and as effective as possible. Then ultimately, your analysis needs to look at all that data you're collecting through those incidents and ultimately drive to a root cause of those so they don't reoccur. So let's start picking apart the life cycle and looking a little bit deeper into each area. So the initial interaction, so meeting the users where they're at. So you can see here, this is sort of a traditional view. They might have some messaging channel. Could be that they're raising things through portal or email, or maybe a telephone call. And that's being routed to a live agent. Now, you very much don't want your live agents having to deal with all those demands. A lot of them could be quite simple. And also, users themselves don't want to have to always talk to an agent for those. So, it's very typical in between those is to introduce some sort of chatbot, in this case, virtual agent, which is providing a messaging interface between the user and the live agent and drawing on the information that you know about that user as well, and presenting to them in as natural a way as possible that information. So that's a very typical step, and one that many companies go through. But still, things like chatbots can require a significant amount of work to identify topics, build out the flows, and ultimately to give an environment, an experience that is good for the users. One way of really driving this forwards is moving away from those traditional sort of chatbots, but to something which is using a large language model for that work. And in this case, you can then still provide that sort of interactive experience to users on a messaging channel, but it's a much more natural conversation. It's using sort of two-way conversation with the AI bot, potentially things like AI search, pulling information from a range of different sources and presenting that back to the user. And ultimately, this is going to give a self-service, hopefully with instant, that immediate gratification answers to sort of common support, and really doing that in a personalized way as well, because it knows about the user, it knows what equipment, what profile they are, where they are, and really making that ultimately a more efficient method. And that's really using advancements in this whole area of conversation interfaces, from the original sort of chatbot all the way up to sort of large language models. And what you're trying to do ultimately is minimize the number of transfers from that messaging channel to the live agent. So if you're having to route to a live agent, then you can make that routing as efficient as possible. And there's a number of methods for it. These methods are not strictly machine learning, but they are using that data that's accumulated to make the operation more efficient. And just looking at some of the methods, so capacity based, so are the agents able to handle that work, not just looking at the work they're managing through channels, but also perhaps the assigned instance that they've got. If everybody's busy, then who could that work go to as a backup? It's always good to be able to handle those spikes in demand and do that gracefully rather than just sticking people in a queue. Skills-based routing. Who knows how to deal with it? Who has the appropriate skills so that they're not ultimately causing escalation to a group that has those skills to deal with it. So get it to the right person quickly. And agent affinity. Is this something that the agent has already been dealing with? Is it a customer? Is it a user that they've worked with historically over time? So they've built up an understanding, and again, that speeds up the resolution. So once you've got it to the agent, then it's important that the identification and the classification is done correctly, because that's the thing that's really going to help you direct the work and source information to ultimately resolve it. And classically, that's done by the agent looking at a range of information that's coming in, and maybe populating that, and on the basis of that is then classifying it and helping to further narrow down what ultimately can be done to resolve it. If you get this wrong, then incorrect identification classification can result in delayed resolution, decreased user satisfaction, increased costs because you're doing further instant handling. And I think one of the things which really is important here is when you're doing this manually, it relies on the experience and the training of an agent. Service desks traditionally have quite a high turnover. So if you've got a high turnover of staff at level 1, then your error rate can be exacerbated by this. So this is clearly a step where if you can remove the human out the loop and make it a data-centric approach, then you're going to drive efficiencies for the organization. one way to do that is use something like task intelligence, which takes that wealth of data that you've got and really performs the same action that the agent is doing, but based on the data that's accumulated in the organization. And the human loop doesn't necessarily have to be totally out of it, because things like task intelligence can have a range of recommended actions. So it can just autofill those fields and away you go. It can recommend which the agent can then decide to accept or not, or in the background do prediction, which again provides additional data to understand the confidence that the machine learning is doing, and ultimately allow you to tune and improve that model so that there's less and less of that manual handling. So let's move on to the response. So we've worked out what it is, we've sent it to a right person, and now it's really down to somebody to work on the response of that incident. And typically there's a sort of diagnosis and resolution steps. If we call the first part, which we've just gone through the triage, we're now into the diagnosis and resolution. So you can see here the agent works on an incident, and they're going to use a range of different sources to help them in the diagnosis. This can be knowledge bases, similar incidents, looking at the details supplied, working with other colleagues, and ultimately using this collective information to determine what's the right steps to resolve. And when they're resolving, they're probably doing some other actions. They're ultimately got to keep the user informed of what's happening to it, so that the user is confident that something is being done. And they might also do things like create a knowledge article for reuse, so that again building that collective understanding so that it speeds up any reoccurrence of similar incidents in the future. Now, there's various methods which we can use to again break this down and speed it up. So let's have a look at that. So firstly, the whole search can be made more efficient through the use of AI search. AI search indexes data from a range of sources and using that data to improve the user search experience. And this is not just only for the agent, but can be also for the user themselves, so that those channels that the user is using are made more efficient. And you can see there it's presented on a range of different applications to help them. So that's making that diagnosis step more efficient. Resolution is still looking pretty much the same. We can step this up again in terms of the diagnosis with the use of similarity. So we spoke about agents searching for similar incidents, what's happened like it before. Similarity as part of predictive intelligence can really do that for the agent. It can present the agent with similar incidents and say, look, here's 3 others that look pretty much the same, and so they can look at those resolution steps. It can also take a step further and say, actually, there's quite a lot of incidents which all look similar. Maybe that's a major incident. So again, individual agents never see those, that spread of incidents across the desk. But things like the models through predictive intelligence can and help make some of those calls for the agent, because they're looking at a wider range of data. And ultimately, what you're trying to do is reduce your MTTR. So that mean time to resolve, you're trying to bring that down through the use of predictive intelligence. Resolution step, still the same, but we can again step that up. With Now Assist using large language models can do a lot of that resolution work and really accelerate that for the agent. So we can summarize the incident. If you're, say you got a follow the sun model and you're taking on an incident that somebody else had worked at. There might be several notes in there that you've got to sift through and get your head around before you can do some work. Incident summarization really does that for you. It condenses it into a much more succinct summarization without working through things like resolution note generation. So what are the steps you've done, and presenting those in a way that can go out to the user, or ultimately, those resolution notes can be the formation of a knowledge article. And then chat summarization. Chats can be quite short, snappy sort of interactions. So bringing all those little bites into something that's summarized and makes better sense. Again, Now Assist can help you with on there. So that's got to the point of the incident being resolved, but what's going to help stop those incidents reoccurring again? Let's have a look and see what's available. Well, on the analysis side we've got things like clustering. So clustering really looks across the range of different incidents. It can help alert service owners to major incidents as they develop, and things like process mining. So let's just dig into each one of those. Clustering divides data into groups that then can be used to identify patterns. After the clusters are made, you get a tree map plot appears on the cluster visualization, and you can review that to identify use cases, candidates for things like automation. Recommended solutions can also be identified for those use cases. And ultimately, reducing the manual effort of workflows impacts both the resolving team, which is a cost reduction, and the users supported, the end user's productivity. And this combination really helps drive your MTTR and MTTF down. Process mining provides you with powerful insights into your business processes. So it looks across all that data and helps pinpoint opportunities for improvement through efficiency, automation, and more. So it helps you identify areas such as, where's the business spending or wasting the most time? What's the root cause behind slow performing processes? Where should the business apply automation next in its process? Where's the rework occurring? What's the estimated cost and potential savings if you to apply these improvements? And how much deviation is the business seeing in its process? So ultimately, this leads to improved visibility, an increase in efficiency, and reduction in costs. So that's quite a lot of the capabilities, but let's just try and summarize this and where all these capabilities fit within the cycle. Interaction, you are trying to make that contextually aware by using the resources that you have available when interacting with the user. Identification, classification, you're taking that wealth of data that you have available to you to make good informed decisions around routing, categorization. For response, using technologies such as Now Assist to help summarize, create knowledge bases, drive search engines, and ultimately make that a more efficient and effective part of the process. And you combine both identification and classification together with response with things like service operations workspace, which provide that single pane of glass for the first line agents. And then with analysis, using technologies such as clustering, process mining to take that data and look for efficiency gains, process improvements, and also you can use capabilities such as continuous improvement management to then drive those improvement activities within the organization. We said at the start all this had to be measured, and typical measures that people look for, outcomes, is things like reducing the incident workload, escalations, and increasing the resolution efficiency. There's a number of metrics that are appropriate for these, and here are a few that could be used, and these are available through success dashboards, and you can also compare yourself against your peer group in an anonymous way by using benchmarks as well, so you can measure not only your performance but how you're performing in the wider context. There are three takeaways from this really. Is firstly, identify your outcomes. This is important. Identify them, get people on board with them. Deliver in phases. You don't have to do everything immediately, but work on the most important things first and deliver against those. And finally, measure the results. Is what you're doing is effective, demonstrable, and communicate what's happening as well, so people buy in and allows you to move forwards. How can I do this? Well, there's a wealth of information on Now Create that's readily available against all the capabilities we talked about today, along with methodology for delivery. So recommend having a look there. Thank you for your time.